Good afternoon. We are on day 3 of our inequalities unit, and today we're going to be covering 2 different topics. One of them is solving absolute value equations, and the other is how to use a sign chart, particularly when solving quadratic inequalities, which can be tricky. So we're going to start with the absolute value. I've put a column down the right side of my page. I'm going to put the instructions down the right side and the math on the left-hand side. So if you need to pause the screen a moment to get your page ready, go ahead and do that. All right, here we go. Our inequality is the absolute value of 3x plus 1 over 5 is less than or equal to 6x. All right, so the very first step that you want to do when solving an absolute value equation or an absolute value inequality equation, so step number 1, is you want to isolate the absolute value, which basically means you're going to solve for it, just like you would solve for an x. So in this case, I need the 5 to be moved over to the right, so I'm going to multiply by 5 over 1. The 5's cancel. Now I have the absolute value of 3x plus 1 quantity less than or equal to 30x. All right, so the second step, now that the absolute value is alone, is you are going to evaluate, that's the term, evaluate the absolute value, which in layman terms means we're going to split it into its positive and negative components. So I'm going to have a positive side and I'm going to have a negative side. And I'm going to go ahead and draw a line between those. Helps to organize the work and keep things tidy. So once you've evaluated, there are no more absolute value symbols. So you have a positive 3x plus 1 in parentheses. Now, here's where we're also going to change it up a bit. The positives and negatives, the less thans and the greater thans, they get a little mixed up with inequalities, particularly if there's an x on the right. So what we're going to do is we're going to solve for the boundaries, and that's your third step here. We're going to solve for the boundaries. And then we're going to worry about the inequality. And the boundaries are the end points, of course, in a graph of this function. So I'm going to change this to an equality because we're not going to worry about the inequality on this step. So on the right, I have a negative 3x plus 1 equals 30x. Notice the absolute value bars are gone because we have evaluated the absolute value by splitting it. That's what an absolute value is. It's a plus or minus. So I have 3x plus 1 equals 30x. I'm going to go ahead and subtract 3x and solve on the right. So 1 equals 27x. Multiply by 1 over 27 on both sides. I'm going to flip-flop my answer, so x is on the left. X equals 1 over 27. That is a possible boundary. All right, on the right, I'm going to distribute the negative. So negative 3x minus 1 is 30x. I'm going to add the 3x over to the right. So negative 1 is 33x. We're going to multiply by 1 over 33 to get the 33 to cancel out. And I've got x equals negative 1 over 33, which is my other possible answer. Okay, so if this was an equality, we would actually do this the exact same way. We need to test to see whether these two values are true in the expression. And in an inequality, we do the same thing. We test the values into the original and see if they work or not. Okay, so let's put this into the original. So and I'm going to go ahead and write 3 over 1 instead of just a 3 times 1 over 27 plus 1 over 5. The question is that less than or equal to 6 times 1 over 27? Okay, so I know that 3 is going to go into 27 9 times, so I'm going to save myself a little time and get a common denominator of 9. So then I have 1/9 plus 9/9 is 10/9 in the absolute value. Absolute value of 10/9 is 10/9. And then we eliminate the bottom by multiplying by 1/5. And we get 2/9. All right, so when you check, it's like double yellow lines, do not cross. We're going to simplify this. It is 6/27, which ends up being 2/9. If you have an inequality without the bar, so less than or greater than, equal, it will still work. Just be ready for some weirdness in your answer. As it is, 2/9 is definitely equal to 2/9. So 1/27 is a valid answer for our boundary. Okay, I'm going to do the same thing with -1/33. I'm going to substitute it in. So absolute value of 3/1 times -1/33 plus 1/1 quantity all over 5 is that less than or equal to 6 times -1/33. Double lines do not cross. We are checking, not solving. Just simplify straight down. So 3 is going to go into 33 11 times. So I'm going to need this to have a common denominator of 11. So that ends up being -1 plus 11, which is 10/11 all over 5. Absolute value of 10/11 is 10/11 over 5. Multiply the bottom by 1/5 and the top by the same thing. And we get 2/11. On the right-hand side, 6 times -1/33 is -6/33, which reduces to -2/11. Now the question is 2/11 less than or equal to -2/11? The answer is no, which means we can go up here and -1/33 is extraneous. So that is not a boundary. So we only have one boundary. We have 1/27. All right, I'm going to draw a line here. Okay, so we solved for the boundaries, and then step 4, which is what we were doing here. Step 4 is test the boundaries. And remember, as long as it is equal, it's fine. Less than or equal to, greater than equal to, yes, it has to obey that too, but equal is always good. All right, so now we're going to switch gears. The 5th step, which is what we're going to do under this line, is we are going to test the intervals. This is how we figure out what the less than or the greater than is doing to our equation. So draw yourself a number line. Now, this is not an actual graph, so it doesn't have to be perfect. It's just a number line. Throw your boundaries on. So I only have one boundary, so I'm going to put 1/27 here. Now, on our original equation, it's a less than or equal to, so I'm going to fill that in just to remind myself that it is equal to. So however many intervals you have between your boundaries, you're going to test. We only have one boundary, so we're going to test right and left. And pick something easy, like 0. That's a nice easy number. And 1. Any number on that interval will sufficiently test the interval. Okay, I'm drawing another line here. Trying to keep this as tidy as possible. So what I'm going to do is test 0 in the original equation. So here we go. Absolute value of 3 times 0 plus 1 quantity over 5 is that less than or equal to 6 times 0. Now in this portion of testing, it has to obey all of the inequalities. So whereas before on the boundaries equal was always good, here when you test the intervals, it must obey must obey the, sorry, there we go, must obey the less than equal to, greater than equal to, less than, greater than. Whatever that is, it has to obey what the sign is. So 0 plus 1 is 1. Absolute value of 1 is 1. 1/5. 6 times 0 is 0. Is 1/5 less than or equal to 0? No. So no, none of our graph is on this interval. All right, let's test the 1. 3 times 1 plus 1 in absolute value over 5. Is that less than or equal to 6 times 1? Well, 3 plus 1 is 4. So absolute value 4 over 5, which is 4 over 5. 6 times 1 is 6. Is 6 greater than or equal to 4/5? The answer is yes. So the little detective work, we figured out that all of our solutions are to the right of 1/27. There are none to the left. So if we have to put our answer together, so step 6 is write your answer. And in this case, x is greater than or equal to 1/27. If they want it in interval notation, it is 1/27 inclusive up to positive infinity. That would be the answer. I know absolute values take time. If you haven't done them before, it's going to be a new experience. But they are a lot of fun because it's definitely detective work, which I really enjoy. I'll put that up there just a second. Okay, we're going to go through another example, but we're not actually going to finish it. It's how you solve a double absolute value. So I'm going to show you how to go about doing it, and then you'll finish the solving on your own. So let's say, for example, 2, you're trying to solve 2w minus 3 equal to the absolute value of 5w plus 1. So normally what you would do is you would evaluate the absolute value, and you would do that by splitting into positive and negative pieces. Okay, well, both of these can be either positive or negative. So the possible combinations of this would be a positive on the left with a positive on the right, a negative on the left with a negative on the right, a positive on the left with a negative on the right, negative on the left with a positive on the right. If both of them are positive, positive and positive, then the signs are going to be the same. If you have a negative parked in front of it, because you can multiply both sides by a -1, you can actually convert this into a positive positive. So these two situations are actually the same. So your equation would be a positive 2w minus 3 equals a positive 5w plus 1, because the double negatives could be multiplied out. Now, looking at the other two, if I take this first one, and if I multiply both sides by a -1, the left will become negative, the right will become positive, and these are the same. So in that case, you would solve, and it really doesn't matter which one you use. You could either do a positive 2w minus 3 is a negative 5w plus 1, or you could pick a negative 2w minus 3 equals a positive 5w plus 1. One of the two. So basically, when you're solving this, you would solve this one, and then one of these two. You'd have two sets of answers, and then you would test. So that's how you approach it, is you end up with two equations that you're actually going to solve, and each one will give you one answer. And don't forget, you'll have to test. Test it, and when you test it, go to the original, just like what we would normally. Same thing with this one, it'll give you one answer. you need to test it into the original and make sure that it is not extraneous. All right, so that's how you go about solving a double absolute value. It's really fairly simple. It's actually easier than a single absolute value in some ways. All right, example 3. Okay, we're going to solve the equation 6x squared minus 13x plus 6 is greater than or equal to 0. Okay, so if this was an equality equal to 0, you would then select one of two methods. You would try to factor to solve. That's the easiest. If that doesn't work, you'd probably do the quadratic formula or completing the square. Those are generally the two that we like. So just like with the absolute value, when you solve a quadratic, the first thing you're going to do is find the boundaries. And so this actually does factor into 3x minus 2 times 2x minus 3 equals 0. And of course, I'm just going to put dot, dot, dot. We end up with two different x values. X equals 2/3 and x equals 3/2. 2/3 and 3/2. So these are our boundaries. Now, if you're just doing straight up factoring, these are both going to work. It's going to be fine. For quadratics, simple quadratics like this, you could get one answer, two answers, no answers. Those are kind of your three possibilities. But the answers for what we're going to be doing, you can count on them. You do not have to sub them back in and retest them. So number 1, find your boundaries. We have 2. The number 2 step is graph the boundaries. So I'm going to draw, and again, this is it's more of a sketch really than a graph. It's not an exact graph. And I'm going to put 2/3 on this side. I'm going to put 3/2 on this side because that's where they would sit. So graph the boundaries. Step 3, test the intervals. All right, testing the intervals. Now, when you test the intervals, we're going to use what's called a sign chart. Our original equation was greater than or equal to 0. So these boundaries are already a winner because they are equal to 0. So we're good there. The question is, where is it greater than 0? So for your sign chart, you're looking for where the result is positive. So we don't really care what the result is exactly. We just need to know, is it positive or is it negative? Okay, so we're going to test. I'm going to pick 0 because that's one of my favorite numbers to test. I like 1, nice and easy, and I'm going to do a 2. So you take your test value and you substitute it in. So 6 times 0 squared minus 13 times 0 plus 6. The question is it greater than 0? It's not going to be equal to 0 because those are our boundaries. Sorry, let me move this up. So 0 minus 0 is 0, and 6 is positive. 6 is positive. It's greater than 0. So everything on this interval will be greater than 0. We put pluses to show that they're all positive numbers. Okay, now the 1. I'm going to go 6 times 1 squared minus 13 times 1 plus 6. So 6 minus 13 is a negative 7, plus 6 is a negative 1. Negative 1 is negative. So that's a negative interval. And then the last one, the 2. 6 times 2 squared minus 13 times 2 plus 6. 2 squared is 4, so 24 minus 26, negative 2 plus 6 is positive 4. And that interval is positive. Okay, we are looking for where our function is greater than or equal to 0. So we're looking for where it's positive and where it's equal to 0. Remember, at these points exactly it's equal to 0. So we actually have our answer here. Our answer is an interval that goes from negative infinity up to 2/3 inclusive in union with 3/2 up to positive infinity. Now, if our equation had been less than or equal to 0, so I'm going to put a little sidebar out here. So if it was 6x squared minus 13x plus 6 is less than or equal to 0, the work would actually be identical. Even the sign chart would be identical, except that our solution would be from 2/3 to 3/2 inclusive, because that's where it is less than or equal to 0. The other thing I want to show you is when you're trying to figure out if these intervals are positive or negative, sometimes using factored form is actually easier. For example, if I took x equals 1 and I used factored form to determine whether the result is positive or negative, it's much faster math. 3 times 1 is 3. 3 minus 2 is a positive number. 2 minus 3 is a negative number, and a positive times a negative is a negative interval. For x equals 2, 6 minus 2 is a positive number, 4 minus 3 is a positive number, and a positive times a positive is a positive. And we'll do the 0. 0 minus 2 is negative, 0 minus 3 is negative, and a negative times a negative is a positive. So when you're doing your sign chart, you can use factored form to figure out where it's positive and where it's negative. Or you can sub in, but the factored form tends to be a little bit easier and a little bit faster to work with. Okay, let me flip the page here. And graphically, when you're doing a quadratic, and let's go back to our quadratic, 6x squared minus 13x plus 6 is greater than or equal to 0. Remember that a quadratic is basically a parabola. So if I were to sketch this parabola, it has 2 zeros. It has one at 2/3 and another one at 3/2. My a value is positive, which means it opens up. So my parabola looks something like this. If you want to know where the parabola is greater than or equal to 0, here's where it's equal to 0, here's where it is greater than 0. And that is why our solution has 2 pieces, because there are two sections of the graph that are actually greater than or equal to 0. So now you can kind of see why negative infinity up to 2/3 inclusive in union with, so skipping over to 3/2 inclusive up to positive infinity is showing you the 2 branches. In the case of it being less than 0, it would be this piece right here that's less than or equal to 0. So it would only be a 1 piece. Okay, I think that's about it. So sign charts are how you figure out where quadratics are positive or negative. They're really the easiest way to do that. If you need to rewatch the video a second time, feel free to do that until you think you've got it. Have a good afternoon.